what we're starting today is Chapter 7. Chapter 7 is going to revolve all around rational functions. So what we're going to be looking at is rational functions and rational expressions. Rational function and rational expressions. Now, at the beginning of the year, all the way in August, we talked about rational numbers. And rational numbers are any number that can be written as a fraction. So rational functions and rational expressions are going to be functions and expressions that are going to be written as a fraction. And more specifically, it's going to be that we're going to have variables in the bottom of the fraction. That's when we talked about polynomial functions, where we said if a variable is in the bottom of a fraction, it is not going to be a polynomial function because it's going to be classified as rational. Now, before we start delving too far into these rational functions and operations with them, we're going to be looking at direct and inverse variation. So you've learned, or if we have not, you will today, that y equals a of x is going to be a direct variation. Now, the reason we call it a direct variation is because as one variable increases, the other is going to increase. It's direct. Or if one decreases, the other will decrease as well. So we can say y equals a times x is direct variation. And if we looked at an example of this here, because a is just going to be a constant number, and it will remain the same for any direct variation. So we could say 2. So y equals 2x is a direct variation. Because whenever x is 1, so if x is 1 and we plug it into this here, well, 1 times 2 is 2. So the y value for this here would be 2. So when x is 1, y is 2. Now, if we increase x to, say, 3, well, 2 times 3 would be 6. So when the x value increased, the y value increased. This is why we call it a direct variation. Now, we can also decrease the x value to, say, negative 3. And it would be negative 6. So as the x value decreased, the y value decreases. This is why we call it a direct variation, because as one increased, the other increased. As one decreased, the other decreased. So this is direct variation. Now we can have it as y equals a times x, or if I divide both sides by x, we get y divided by x is equal to a. And it doesn't have to stay in y divided by x. It could also be x divided by y. If we have the two variables being divided by each other, we get the constant term. Because again, a is just a constant number. So really, either one of these forms is still considered direct variation. Now we also have inverse variation. Well, direct variation meant as one increased, the other increased, or as one decreased, the other decreased. What do we think inverse variation is going to be? Well, exactly what both of y'all actually said. Because if one increases, the other is going to, and as one decreases, the other will increase. It will be in opposite directions. And the main form of this comes in y equals a divided by x. Where again, a is the constant term. Now we can do the exact same thing, so why not? I'll stick with 2. It doesn't have to be 2, it could be any number, but I'm just picking 2 arbitrarily. Now we could do the exact same thing. We could say when x is 1, well, 2 divided by 1 is 2. And that just mainly gives us a starting point to kind of reference it back to. Now, if we increase the x value, well, I'm going to increase it to 4 because it's going to be a little bit nicer number to look at. 2 divided by 4 is almost 1/2 because the 4 will be on bottom. And if we look from 1, 2 to 2 or 4, 1/2, well, the x value increased, but the y value decreased. Okay, well, let's go the other direction. Let's decrease x, and let's not take it all the way to the negatives. Let's just take it to 1/2. And 1/2, or 2 divided by 1/2 actually works out to be 4. So as we decrease the x values, the y values actually increase. Now, negatives don't really help us here too much because we could decrease it to a negative. Because I could plug in -1, but that still would give us -2. It doesn't actually work the same with negatives. But it is this opposite direction. Now, another way we can look at this is I can actually multiply both sides by x, which really tells us x times y is equal to a. And it's really, both of those is just seeing it in terms of the constant a and in terms of y. And each one of the versions has its own use. So, for all these here, direct, try that again. Direct variation can come in the form of y equals a times x, or we could say y divided by x is equal to a. And the y and x can be flipped, depending on how we want to set it up. We'll normally set it equal to y. And our inverse, really we can say is y is equal to a divided by x, or y times x is equal to a. Now what we want to look at is these three here and determine whether it's direct, inverse, or neither. So we look at the first one, y times x, or x times y is equal to 5. Would that be direct, inverse, or neither? Inverse. We can call this inverse because we could divide both sides by x also, which would tell us y is equal to 5 divided by x, which is by definition the inverse. So inverse and direct variation by definition kind of come in these two forms here. By definition, these are the two equations. Now, for the top one, for direct, what we can do is we can actually divide both sides by x to get a by itself, the constant term, which generates this here, y divided by x equals a. So realistically, those are both direct variation, because one's going to increase, the other is going to increase, or vice versa. Now, for inverse, we have y equals a divided by x. And if I multiply both sides by x, this side over here is just going to reduce to a, and the other side is going to become x times y. So those are both inverse. Yes? Now, keeping those in mind, when we look over here at the first one, I do have the two variables multiplied together, and it equals a number. Now, when we look at the general case, a is just a number. It's just a term. It's a constant. A is kind of by definition a constant term. It's just going to be a number. So, when we look at this first one here, x times y is equal to 5. It kind of follows along with this here. X times y is equal to a. So since it does match that there, we can say that a is inverse. If I wanted to, I could divide both sides by x, which tells me y is equal to 5 divided by x. which is also represented in an inverse form. We don't have to. We're just talking about it being an inverse. Does that make sense? We'll look at B here in a second, but how about C? Y divided by 2 is equal to X. It would be direct. Because if we want to get it into a better form, I could multiply both sides by 2. Here the 2 and 2 would cancel, telling me y is equal to 2x, which is one of the forms, y equals a times x, yes? Now, for direct variation, as we described it, we're pretty much saying as one increases, the other increases, or as one decreases, the other, they're going in the same direction. So really, the form y equals a times x for direct variation is really a variable is equal to a constant times another variable, yes? So we can see it here, y equals 2 times x, yes? Well, I'm going to erase this here. Y divided by 2 is the same as saying y times what? Because how can I rewrite a division of 2? It's the same as multiplying it by 1 over 2. Because 1/2 times 2 is the same as dividing by 2, yes? So 1/2 y equals x. Do I still have a variable is equal to a variable times a constant? It's still in the same format, but because they changed it from x being multiplied by that constant to y, we sometimes have a tendency to kind of not see it as the same. But these are the same. We could do the multiplication of 2 to get it to be y equals 2x, or see that x is equal to 1/2 times y. Because the big part about it being an inverse is that the variable is either in the bottom, where the constant term is on top, or they're both next to each other. X and y are both next to each other. So this here would be direct. Now B. It is neither. Why is it neither? It's not in the formula, but there's one other key part to it that's different. Exactly. Because when we talk about direct and inverse variation, we're also only talking about multiplication. That subtraction is really where it's not either. This here would be neither, and it's really based off that subtraction. Okay, we're going to move on here in a second, but I still want to just say one more thing with this here, and it's probably not just me, you're probably not questioning too much, but like the 1/2 might be seeming like it's decreasing the value of y. But again, whenever we're looking at this here, we're talking about x and y's increase or decrease relative to each other. Because as x increases from one amount to another, we're not talking about just the increase, but how it's changing from one x value to the other. We're also talking about y changing from one value to the other. Does that kind of make more sense? It's not relative to x and y, individual points. It's how as I'm moving from one y value to the next and one x value to the next. So sometimes it might look like x is increasing more than y, but as long as it's staying at the same rate, that's what's more important. Because we have a tendency to not handle having a value with y as easily with x. Now, looking at these next three here, number one would be, as well, it does follow and is set up in the exact same way of y equals a times x. So it would be direct. How about number two? Because we can divide both sides by x, which would tell us y is equal to negative 0.25 divided by x, which would be our inverse. And number 10 would be, and what's the big giveaway? The addition. Yep. So really the big giveaway with any of these here is if there's addition or subtraction, it's automatically neither. Any other questions on this here? Now, when I say that, we need to make sure that the variables are either being multiplied or divided. Because this one here, it's not on your note sheet, but would this one here be inverse, direct, or neither? Yeah. Really, if the variables aren't attached to each other and there's addition and subtraction, then we can say it's neither. Because when we look at this one here, well, there's no way I can get x and y multiplied or divided. They're at addition and subtraction. We look at the previous one, x minus 4. Well, if I get the variables on the same side, well, it's x minus y. Those two variables in relation have to really have a multiplication or division property to them. I think that's the better way to think of it, is that these two here are either going to be multiplied or divided. We can only have one or the other. We can't have them added or subtracted. To where, in this case down here, x and y are together with multiplication. They're nowhere else. It's just that our constant term got subtracted from them, just to put on the same side of the equation. And that's kind of the main difference. Any other questions on this here? So going from the top, x times y is equal to 17 would be inverse. Y is equal to x plus 29. Neither. Y divide direct. Okay. One more thing. Tell whether x and y show a direct inverse variation or neither. So when we talked about these here, as one increased, the other increased. As one decreased, the other decreased. And they do this in a uniform manner because they all have a constant term a. There's a constant term for each one. Now, most of the time, we've been switching between the two forms. Y equals a times x, and x, or y divided by x, is equal to a. Or we can say a is equal to x divided by y. For direct, inverse, y is equal to a divided by x. Or we can say that x times y is equal to a. So for these here, having a by itself is going to be a better way to actually look at these. Because if I take those x and y values, so we'll say for a, and divide them, so we can say y divided by a, so negative 12 divided by 2, and negative 6 divided by 4, and negative 4 divided by 6, and negative 3 divided by 8, If it is direct, I should get the same term because it should be that constant amount. If not, that means it's not a direct variation. So inverse, a is equal to x times y. We can multiply them together. And if I get a constant term, it means it is an inverse variation. So really, we're using the fact that a is equal to y divided by x, or a is equal to x times y, to determine whether or not it has an inverse or direct variation. So we can check for a direct variation first, doing y divided by x, or x divided by y. Either one, we need a constant amount for each one. So if we do y divided by x, well, our first one would be negative 12 divided by 2. And well, negative 12 divided by 2 is negative 6, yes? Then we do the next one, negative 6 divided by 4. Or negative, I think, 3/2. Yep. Well, I can stop there. Because if this is a direct variation, the value of a should be the same. It should be the exact same across every single term. Well, I already have 2 that are not. So it tells me that this is not a direct variation. So we look at inverse variation. So we should have a constant term is equal to x times y. So we can say 2 times negative 12, which is negative 24. Okay. 4 times negative 6. Okay. 6 times negative 4. Negative 24, because that kind of flipped from the one before it. And 8 times negative 3. We got the exact same value across all 3. So this would be a direct variation. Or not direct, inverse. Sorry. It would be an inverse, because y equals x times a is our inverse form. And if we look at the x values and y values, 2 to 4, 4 to 6, 6 to 8, it is getting bigger. And the y values are technically getting smaller. They're bigger for negative sake, but in overall value, not the negative included, but the number itself is going down. So this would be an inverse. Because if we kept getting a bigger x value, this would actually go 2, 1, and then start getting into very small numbers. Now, if we look at the next one here, 1, 2, 3, 4, 2, 4, 6, 2, 4, 8, 16. So most likely direct, and we can try it first. So I can say 2 divided by 1 is, well, 2. And then we can say 4 divided by 2, 2. So 8 divided by 3 is 8/3. And let's just do one more. 16 divided by 4 is 4. This here is not direct. Yes? So it's not direct. All right. I'm going to erase this here so I have a little more room. And if we try inverse, 2 times 1 is 2. 2 times 4 is, so this here is neither. It's neither direct or inverse variation. It would actually be a quadratic function. Any questions on A or B? Let's look at 4 and 5. So we can do 20 divided by -4 first. Y divided by X. And so it'd be -5, yes? 15 divided by -3. -5. Even though that we do have this pattern, I would run it all the way through all the numbers that they give us. 10 divided by -2 is, and 5 divided by -1 is -5. They're all -5, so this would be. And if we look at the actual numbers, not dealing in the negatives, because it took probably a while for y'all to get to the understanding, the bigger the negative, the smaller it is. But we're just looking at the numbers itself, and as we go 4, 3, 2, 1, the numbers are getting smaller, not by negative values, just by the number itself. And if we look at the y values, 15, they're decreasing as well, because we're coming down to 0. Because if we look at graphically, not that way, we're more looking at a line like this. Because 20, 15, 5, 10, 5, 4, 3, 2, 1. Just decreasing. And they're both decreasing, they're coming closer to 0. Okay. Let's look at the next one. So it's not direct, because we can see that from 60 divided by 1 is 60. 30 divided by 2 is, okay, well that's not going to work. The other is going to be 60 times 1, which is 30 times 2 is 20 times 3, and 15 times 4. So this here would be an inverse variation. Any other questions on this here? Do we need to see another example of one of these here? Okay. And this is the last thing we're looking at. And this is dealing with inverse variation. Now with all of these here, and especially on the homework, it's going to ask for two things. One is going to be the equation, and the other is going to be a value. The variables x and y vary inversely, and y is equal to 4 when x is equal to 3. Write an equation that relates x and y, then find y when x is equal to -2. So we want to write an equation first that relates x and y inversely. Well, that'd be y is equal to what? A over x, because that's just the definition of inverse variation. Y is equal to a divided by x. So if I want an equation that relates x and y, I really just need to find the value of a, because that's the only real value that we need. A is a constant number. And if I have it, I do have an equation that relates x and y. Now, they did tell me earlier that y is equal to 4 when x is equal to 3. Well, for our equation here that we wrote down, well, we have y, x, and a, yes? So if y is 4, when x is 3. The only thing I'm missing is the a. And exactly, and how did you get to 12? Right, I'm going to multiply both sides by 3. These would simplify, exactly tell me a is equal to 12. So our equation would be what? Y is equal to 12 over x. So there's half of the answer. Our equation relating x and y is equal to 12 divided by x. Now this one here, you might be wondering, why are we not using the other form, x times y equals a? Because we can, but it does, having it set up as y equals a divided by x does help us get to the correct form a little bit easier. Now the other half. Find the value of y when x is equal to negative 2. Well, our equation, y is equal to 12 divided by x, yes? Well, what did it tell us x was? And that's it. And we can see that this is, yep. Any questions on this here? No? All right. Let's look at least one more, because the rest aren't really going to change that much from this here. Okay. So looking at this here, all right. So the variables x and y vary inversely. And y is equal to 8 when x is equal to 4. Write an equation that relates x and y, then find y when x is equal to negative 16. So our equation, y is equal to a divided by x. Now it did give us some helpful hints to figure out what the values of a is, or the value of a, because it told us y is 8 when x is 4. So we can say 8 is equal to a divided by 4. Well, to find the value of a, we can do what? Multiply both sides by 4. Which tells me a is 32. So our equation for this here is telling us that y is equal to 32 divided by x. Now, we want to find out what the value of y is when x is negative 16. So we can say y is equal to 32 divided by negative 16. Y is going to be negative 2. And that is it. Any other questions on this here? Again, this can sometimes get tricky when we're looking, especially jumping from different sides of 0. When x is greater than 0 to less than 0 for inverse and direct variation, because at 0 for inverse variation, we wouldn't actually have a number, because we can't divide by 0. And you all finish writing this down? And I just kind of want to point out, because y equals a over, kind of if we put 0 in for x, we can't do this. Also because the other form would be saying 0 times y is equal to a, and a cannot be 0. Well, this is also why division of 0 doesn't work, because anything times 0 has to be 0. It can't be anything else. So going from greater than 0 to a number less than 0 really starts getting confusing, because at the center point between the two, we get this undefined term. So there is no inverse or direct variation, really. It's kind of 0. Everything kind of falls apart, especially for inverse. But other than that, that's it. I did put a lot more examples in, but I feel like y'all have got the hang of this, of how this works. And that's all we're doing for today. So your assignment is this here on page 369, 3 through 8, 11 through 13, and 15 through 19.